Hey everybody, welcome to this physics class. At this opportunity, we are going to talk about something pretty interesting about Da Vinci. Leonardo da Vinci has created something called Arcade Bridge. Do you want to know more? Let's take it. This is an arcade geometry, right? The geometry of an arc. That's an arc. And that's the same geometry that an arcade bridge do have. Okay, and does have. In this case, the force of the lot, that is the electric motor. The electric motor is being distributed symmetrically. Okay, here the main point or the key is symmetric. Okay, symmetric. Here is distributing the weight here and here at the same time because the geometry is symmetric. Then it means that the angle here is 0. Okay, and here there's just 9 90 90 grades. Okay, that is 90 grades, 90 grades. Here the angle is 0, right? On the top, the angle of the tangent is 0. The angle is all related to the tangent of the coordinates, right? We are going to check this later better to have a better understanding of this. Then you gotta recall this. The main point on the arcade is symmetry. Okay? If the geometry is symmetric, the weight or the load will be distributed symmetrically as well. Teacher, then if my structure is symmetric, the load or of course the weight, the force will be distributed symmetrically. It doesn't matter the point. You have to know that a, a, a force applied on the space will have trigonometric components. Trigonometric components, teacher, what is that about? I really don't know. What are you saying? We are going to check this later on the board. Lay there. We are going to check this there. Okay, but later. Currently, we are talking about this bridge. Okay, here the main point here is that there's geometry. Okay, there's a geometry that the geometry is symmetric. That in this point, that is the topic, that is the highest point, the loads of the charges will be distributed or spread out all over multiple points and will be symmetric as well, right? In that case, we need to know that Da Vinci has discovered something interesting. That if I apply another geometry, the charges, the loads, the weights will be spread out over multiple points instead of one. That's how I can apply the geometry to reduce the weight. Teacher, you are saying me or you're arguing that this bridge reduces the weight, the force. There's something that weighs 100 Newton really in this on this bridge will be weighing 500 newtons instead of 1000 newtons. Let's dive into this topic and let's go over there right now. Then hit me, please. Don't hesitate. If you have questions so far, don't hesitate to ask me. Okay, because the main point here is the geometry. That if the geometry is arc or is arced, it will be smoother to carry out a weight all over this bridge. Why? Because the bridge geometry will reduce on the half the weight. On the half. Oh yes, let's check it out right now. Hey guys, welcome to this better view. Okay, we were talking about the arcade bridge, how the Archimedes bridge can distribute or spread out all other multiple points the same charge. Okay, here there's a symmetry. Okay, that's the first concept that we need to grasp right now. He does this, there's a geometry that's the same than this. Okay, and we can divide this part of this act in 3 points. 1, 2, 3. Also, you can add whatever, as much points as you want. However, I'm gonna just add 3 points. And we need to recall what is the concept tangent of a point of a space in a point and a point in a space. Then what is the space here? There's a x, yeah, wait, right? The x here is, for instance, is 3. Y here is 0, right? Here. Now, for instance, that's 1.5, 1.5, I say 1, 2, 3, 1, 2, 3. This is 1, 2. That's like 2. 2. And that's like I guess that is 1. Okay, those are the points. In that case, those are the coordinates of that point. In that case, the point is 3, right? 0 in x, right? Okay, that's why that's symmetric. Now, in order to keep moving forward, let's recall this kind of thing. We already know why that's symmetric, but now, what is this? We have to confirm that we are understanding this, or to double check, okay? The first part is the point sum of. Sum of means the sum of all the forces located on x is equal 0. It is static. It is meaning that it's not moving, right? The system is not moving. Okay, that's why equals 0 all the time. If you hear once you hear 0 in physics, means no motion, it's static, right? However, if that's different than 0, obviously it's gonna be on motion, it's gonna be moving. Okay, right? The sum of the forces on x, different 0, is dynamic. Let's recall what is the body diagram the body diagram forces. Okay, there are 3 main mechanical forces. We shot them. The main 2 on x, 2 forces: motion and friction. The Shear forces, motion, friction. That's why I'm calling them the shear forces. Okay. Also, here 3 forces on weight: gravity, weight, normal. That's a fact. It won't change never, unless that we repute or we apply reverse engineering on physics and we reconstruct it. But it won't happen. Gravity. The gravity amount. What is the gravity amount? 9.8. Gravity is different than weight. Please, it's an study. That's this information is based on my own statistics. Okay, right? All about my experience, I've been realizing that almost every student around the world is confusing the concept weight and gravity. Okay, the gravity is the mother. It's mass. is mom's weight, okay? Gravity is mom's weight. Gravity, here you can check x, weight, minus weight. Then friction, on the friction is all the time opposite to motion. That's a fact. It won't change. Never. Okay? Never. Okay. If you have got some question, please don't hesitate to ask them on the comments below. Okay? I'm going to help you out them. I will be more than glad that. Okay, here we were talking about in the body diagram forces. Those are the main 5 forces, okay? Why we need to analyze them? Because we need to know how the forces are being spreading out all of that bridge, okay? Because we need to recognize this. We already got it, okay? We got it. Why this bridge is symmetric? What are the sum of the forces? Okay? If the sum is equal to 0, it's static. If the sum is different to 0, it's dynamic. Also, regarding the body diagram forces, they are finite mechanical forces. 2 of them are located on x-axis, right? And those are called shear forces because it's the motion force and friction force. 3 of forces of the remaining 3 of the 3 remaining forces are located on weight and the gravity, weight, and normal. Okay, weight, gravity, weight, normal. Gravity, weight, normal. Don't confuse or don't mix the concept gravity and weight, right? Please be aware with this. And that's all. Okay. We need to know that the weight, the equation of weight is mass per gravity. The mass must be on kilograms. And the gravity, obviously, meters divided seconds. Okay? That's all. What is the difference between use an arched bridge and non-linear bridge? The support, right? Where is the spread out all over 2 points? Just 2 points. Here, it's spread out all over multiple points. And that is symmetric. It's meaning, let me please show you now. Keep moving, advancing, okay, advancing, keep moving forward. And this. The arched bridge. What is this arched bridge? And teacher, I'm not understanding. Because it can't be happening, right? If you're not understanding it, we need to know something. That's the basic point. It's an arched. The arched is symmetric. And due to that symmetric, hear me proper bit. And hear me out, please. Hear me out. To the arched bridge is symmetric. Repeat this. Because due to the arched bridge is symmetric. The forces are symmetrically spread out all over multiple points. Teacher, I'm not understanding you. No, baby. Please do your best all over. Now I have already hydrated myself. Let's move it on. Let's recall that that's symmetric. And the compression equation in this case, okay, what is the compression equation, teacher? You are using a lot of equation today. Why? Because we are the best of the world. Then I have already hydrated myself. Then I have say the compression. The compression force is the one related to the arcs, right? Okay, in this case, that symmetric is saying that the compression on an arc bridge is related about how many points are symmetric. or something like that. That's the logic, right? In order to grasp this equation, you gotta imagine, please imagine like asymmetric point allow me to divide the forces. That it does mean that if there are 2 points symmetric, in this case this and this has this symmetric point, it's gonna divide by 2, or it's gonna have the half of the real amount. In this case, the angle, this angle, you're gonna recall this. What is this angle? This angle is related to this of the tangent of the x-way. X-way is pretty important here. Why? Because that's the angle that I have here. The angle here is 0 regarding the tangent. And cosine of 0 is 1, right? In that case, here, the point is distributed in this and this. The whole for this and the whole for this. Ah, teacher, that's why. That's why the compression equation is saying that an arced bridge is decreasing. Please hear me up. The arced bridge is decreasing the lot on the lot that is on an arced bridge. If the point is here, let me please grab my this here. If the point is here, here the angle is 0. Here the angle can be 30. 40. Okay. 1, 2, 3, 4, 3, 0, 1, 2. 40, 90. For instance, okay? Here is the same. In that case, the angle is 0 here, right? Cosine of 0, 1, right? Then here, the weight here is, for instance, 2 Newton. The compression on that point will be 200 Newton by cosine of the theta, 0. Cosine of 0 is 1 divided 2. It's equal 200 Newton divided 2. It's equal 100 Newton. Oh my gosh, teacher, you have explained me how this socket has been decreasing the amount of the weight that it is carrying all over this. That's right. That's nothing less. Okay. Then please write this down. You gotta write this down because you gotta be explaining this. Okay. Then if you have some questions about how this is a decrease in the charge, the amount, please hit the bell, subscribe, like if you have liked it, like, comment your doubts. If you got some question, don't hesitate to ask them below, okay? Then let's move it on with the next example. Okay, let's continue. In this case, the charge of the lot, the weight is here, okay? 200 meters. Here, we are going to check, we are going to imagine that there are 3 points here. That's the second point. Here, ideally, it should be the 30, okay? 30, for instance, 1, 2, 3. 1, 2, 3, that's right. 30. Okay, no, here. 30, right. 30, 90. But if I check this is on the river. Is the river is inverse. Okay, in this case, I guess that this video has to be let me please grab my it's here. Apologies. Let's do it right. But here's the point. Here, this is the 0.139. Here is the 30 grade, 60 grade, 90. Here is the 0 point grade regarding coseno, right? And let's check that this equation is staying this. Okay, that's the compression equation, that's all. And here, 0 compression on arc bridge. This is saying that this arc will divide on 2 or by 2 the load or the weight, but you have to multiply this by the coseno. Then compression is equal weight. Here the weight is 200 newtons. Okay, 200 newtons by coseno de theta, coseno del ángulo of this angle. What is this angle? 30 divided 2. It must be 200 newtons divided 2. That's the compression force. Then you gotta figure it out by yourself. Well, what is the difference? All the time, if the angle is here, is 0. If the angle is 0, coseno of 0, it's equals 1. So, 1. And coseno 90, 90, right? Oh, 0. Okay? Coseno 90 is equal 0. Coseno 0, 1. Coseno 90, 0. Okay? In that case, 294, you gotta achieve this by yourself. Okay? But the real main point here, and if we achieve together, is half 1, half 1. Then 100 is 2. It means that is here, that is 80 Newton. 80 Newton, I guess. Let's confirm it by yourself, please. Then that's the point. All up to the angle. You can use this equation to figure it out about the weight, the real weight, and how the weight is distributed on that point. Then if you have liked this video, please hit my like, comment, please comment your doubts on the comments below, right? Ask them on the comments below. And see you on the next class. Guess what? It's time to crack the book. Please don't hesitate to ask me if you got questions. And also remember, if you study engineering, you can have the opportunity to change the world. Engineering has been created to change or to apply maths, physics, chemistry, biology concepts on the real life. Then see you on the next video. Hit the bell, subscribe to my channel. See you.